We are given a set X that has 6 elements 1, 2, 3, 4, 5 and 6, and if an arbitrary element of this set is denoted by the letter small n, we have to express the following as sets. So these three conditions have to be represented as three sets. So let's look at the first subproblem. The first set in set builder notation would be the set of all elements n such that n belongs to X but 2n does not belong to X. So let's look at the candidates we have which satisfy the first property. Well, there are 6 elements of X, so there are 6 candidates which satisfy the first property 1, 2, 3, 4, 5 and 6. We also want them to satisfy the second property, which is that 2n does not belong to the set X. So let's look at the candidates one by one. 1 belongs to X. Does 2 times 1 belong to X? Yes, 2 times 1 also belongs to X. So this property is not satisfied by the number 1, so we just ignore it. Let's look at 2. 2 belongs to X, so it satisfies the first property. But twice of 2, which is 4. Does 4 belong to X? Yes, 4 belongs to X. So this property, the second property, is not satisfied by 2 either. Let's look at the third candidate, 3, from the set X. Does twice of 3, which is the number 6, belong to X? Yes, 6 belongs to X. So this property is not satisfied by 3 because this property says 6 does not belong to X. But we know that 6 does belong to X, so this property is not satisfied by the number 3. So we ignore 3 and move on. If we put n equal to 4, twice of 4 is 8, and 8 does not belong to the set X. So 4 is an element of this set. 5 is also an element of this set because twice of 5, which is 10, is not an element of X. And 6 also belongs to this set because 6 times 2, which is 12, is not an element of X. So the first set in roster form is 4, 5, 6, and in set builder form it's this. Let's look at the second set now. The second set is the set of all elements n such that n belongs to X. That's given. N represents any member of X, and n plus 5 is equal to 8. Now the second property is the simpler one, so let's look at that first because it uniquely identifies n as the number 3, because if n plus 5 is 8, then n must be 3, it can't be any other number. Now, is 3 an element of X? Yes, it is. Since 3 is an element of X and 3 plus 5 is 8, 3 is the only number which satisfies both of these properties. So the second set is just the singleton set 3. In set builder form, this is how we represent it. In roster form, this is how we represent it. Now let's look at the third set. The third set is the set of all elements n such that n belongs to X, that's given to us, and n is greater than 4. So which elements of X are also greater than 4? Those are the elements which belong to this set. So let's see which elements of X are greater than 4. 5 and 6. So 5 and 6 represent the elements belonging to the third set. This is the third set in roster form. This is the third set in set builder form.